Chapter 10 Electrolysis. Now let us do activity 10.1 to find out whether electricity is conducted through any substance in liquid form. Here are the things you need: a beaker, 2 carbon rods, an ammeter, 2 dry cells, each of which is 1.5 volts, connecting wires, and you will need some liquid solutions: kerosene, salt solution, acidified water, copper sulfate solution, and distilled water. Now, this is the method of conducting this activity. Connect the ammeter and the 2 dry cells to the 2 carbon rods using the connecting wires. Dip the 2 carbon rods partially in the liquid or the solution that is being poured onto the beaker. Pour the liquid or the solutions are used for this activity onto the beaker, and then observe whether there is a deflection in the ammeter. If there is a deflection in the ammeter, it means that electricity is being conducted through the liquid or solution. Now, these are the observations of this activity. Liquid salt solutions causing a deflection in the ammeter. Salt solution, copper sulfate solution, acidified water. Liquids and solution or solutions not causing a deflection in the ammeter, kerosene and distilled water. Liquids or solutions which conduct electricity are called as electrolytes. The reason they have the capacity to conduct electricity is because they have mobile ions or ions that move. Liquids or solutions which do not conduct electricity are referred to as non-electrolytes. The reason they do not have the ability to conduct electricity is because they do not contain mobile ions or movable ions. For an example, distilled water will only contain water molecules. It will not contain any ions that move. But if you take a solution of salt, it will have sodium plus ions and chlorine minus ions, ionic compounds. They are made up of oppositely charged ions formed by the relevant atoms. Examples: sodium chloride and copper sulfate. Now, if you take sodium chloride, it is made up of the atoms sodium and chlorine. Sodium and chlorine can form ions by releasing electrons or accepting electrons. As you all know, atoms contain subatomic particles, protons, neutrons, and electrons. Protons and neutrons are found in the nucleus, while electrons are found around the nucleus. Sodium atom will release electrons which are negatively charged and become into sodium positive ions. Chlorine atoms will accept electrons and form chloride negative ions. Between these positive ions and negative ions, bonds are formed to form the ionic compound sodium chloride. Now here is the structure of copper sulfate. It is made up of copper 2 plus ions and sulfate minus ions. Solid compounds contain ions that cannot move freely. So solid ionic compounds will not have mobile ions. Therefore, it does not conduct electricity. But if we dissolve an ionic compound in water, we can obtain the aqueous solution of that ionic compound, and the aqueous solution will contain mobile ions. Or we can melt the ionic compound to form the fused liquid. When we melt an ionic compound, the liquid obtained is known as the fused liquid. It contains mobile ions. Now here is a diagram that represents this process. As you can see, the solid ionic compound does not contain ions that freely move. They are tightly bound to each other. But when you dissolve it in water, It will have positive and negative ions that move, and also water molecules can be found. And when you melt the ionic compound, the liquid that you obtain is known as the fused liquid, and it will have only the positive and negative ions of the ionic compound, and they will move. Therefore, the fused liquid and the aqueous solution have the ability to conduct electricity. Therefore, they are known as electrolytes. Now let us try to understand what electrodes are. The conductors through which the electric current enters the electrolyte and exits are called electrodes. Now, if you look at this diagram, electric current originates from the positive terminal of the battery and ends at the negative terminal. Therefore, the electric current will enter the electrode and then it enters the electrolyte. Then it will exit through the other electrode, positive electrode. The electrode connected to the positive terminal of the external supply of electricity. Now, where do you get the external supply of electricity? Yes, that is the battery. Negative electrode. The electrode connected to the negative terminal of the external supply of electricity is known as the negative electrode. The carbon electrodes used in this process are inert electrodes. Inert electrodes are a substance that does not react chemically with the electrolyte. Examples: platinum or carbon rods. Now let us do activity 10.2. The electrodes in this process are carbon electrodes, and the electrolyte is copper sulfate solution. In this process, the electric current passed through the electrolyte solution will bring about a chemical change in the electrolyte. Now, let us look at the observations of this process. Deposition of a reddish-brown substance at the negative electrode. Liberation of gas bubbles at the positive electrode. A gradual decrease in the blue color of the copper sulfate solution can also be observed. Chemical change affected by passing an electric current through an electrolyte is known as electrolysis. So, the reddish-brown deposition on the negative electrode is copper. The gas bubbles evolved at the positive electrode is oxygen. Electrolyte is converted into more simpler components in the process of electrolysis. Now, in this experiment, copper sulfate, a compound, is converted into the more simpler copper, and that copper is deposited at the negative electrode. Electrolysis of acidulated water. Now, in order to do this activity, you need to get a yogurt cup and then make two tiny holes at the bottom. Through these two tiny holes, you need to insert two carbon rods, making sure that half of it is inside the cup and half of it is out of the cup. To the portion of the carbon rods which is out of the cups, connect a connecting wire and a 9-volt battery. Now, the carbon rod that is connected to the positive terminal of the battery becomes the positive electrode, and the carbon rod which is connected to the negative terminal of the battery becomes the negative electrode. And then you need to fill the yogurt cup with acidulated water or water mixed with an acid. You can use sulfuric acid or hydrochloric acid. Once this is done, you need to take two small ignition tubes and put them in such a way that it covers each electrode. Initially, the ignition tubes will be filled with acidulated water. After some time, you will observe bubbles forming at each electrode, and these bubbles will move all the way up and get collected on the top of the ignition tube. Now let us look at the observations of this experiment. Gas bubbles evolve at the electrodes. The volume of the gas collected at the negative electrode is approximately twice the volume of the gas collected at the positive electrode. Now, what gases could these be? Hydrogen gas evolves at the negative electrode and oxygen gas evolves at the positive electrode. So, how are we going to identify these two gases? Now, let us do some experiments to identify the gas. Gas evolved at the positive electrode is collected and tested with a glowing splint. If the splint reignites to form a flame, then you can identify that gas as oxygen because oxygen is necessary for combustion. So, if it has the capacity to reignite the glowing splint and form a flame, then we can confirm the presence of oxygen. Gas evolved at the negative electrode is separated and a lighted splint is put into it. The gas burns with a squeaky pop sound. If that happens, we can confirm the presence of hydrogen gas. So, from this experiment, we can come to the conclusion that electrolysis of water splits the water into more simpler substances such as hydrogen and oxygen. Now, let us have a look at these experiments.
Let's start off with a test for oxygen gas. As you can see here, I've got a gas jar and I've got a burning splint. Well, the test is if that I put a glowing splint into oxygen gas, it should reignite it. So let's have a look at that again. So I've got a glowing splint, the flame's out, and when I put it into the oxygen, it should reignite. So the test for hydrogen gas is when you light the actual gas, it should make a popping sound, more of a squeaky pop sound. Let's listen. There we go.
Now, let us look at the applications of electrolysis. Electrolysis is frequently used in various industries. Extraction of various metals. Example, we can extract sodium and aluminium. As you all know, metals exist in nature in metal ores. They can be found in various places such as the earth crust. So, these metallic ores will contain impurities and many other components. So, in order to extract the metal from these sources, you can do electrolysis. Industrial manufacture of caustic soda or sodium hydroxide. Caustic soda is a very important compound. It can be used in industries of making paper. It can be used to make soap and detergents. Therefore, sodium hydroxide can be prepared by the electrolysis of aqueous sodium chloride. Electroplating. Certain metal items can be plated or coated with another metal in order to get some desirable quality. Here are some examples of electroplated materials. A watch is plated with gold. A mug is plated with copper. A teapot is plated with silver. A goblet is plated with silver. And then a tap is plated with chromium. Electroplating. Recall the observations of activity 10.2. You would have observed the deposition of copper on the negative electrode. By engaging on the activity 10.4, now let us investigate whether copper can be deposited on a certain object. Now here is activity 10.4. To two dry cells, connect some connecting wires and then to the negative terminal of the battery, connect an iron nail. To the positive terminal of the battery, a copper plate is connected. As the electrolyte, copper sulfate solution is used. It is done, you would observe that the copper plate starts dissolving gradually. Simultaneously, a reddish-brown deposition would form around the iron nail. The plating of a certain metal on another surface using electricity is referred to as electroplating. The metal that needs to be plated should be used as the positive electrode. In this case, we need to plate copper, therefore, a copper plate is used as the positive electrode. Object that is plated should be used as the negative electrode. In this case, the object is the iron nail. The electrolyte used needs to be a solution of a salt of the metal that should be plated. Now, generally, what we call salt is what we have in our kitchens, and that is sodium chloride. But in chemistry, a salt is a compound which is an ionic compound which contains oppositely charged ions, positive ions and negative ions. So in this case, the salt of the metal that has to be plated should be a salt of the metal copper. Therefore, we use copper sulfate solution which will contain copper 2 plus ions. Characteristics of a high quality electroplating. The coating should firmly adhere to the surface subjected to plating. The coating should be of uniform thickness. The coating should be shiny. So how can a high quality plating be done? How can a high quality plating be done? By ensuring the electrochemical change to take place very slowly, we can make sure that a high quality electroplating process takes place. So, how can we make sure that the electrochemical change takes place slowly? Using a very dilute electrolyte or salt solution. Let me remind you again, here the salt solution does not mean sodium chloride. Salt solution is a solution made up of an ionic compound which contains positive and negative ions. So, if we use a very dilute solution, we are able to get a good quality electroplating, passing a very low current through the solution. In order to pass a very low current through the solution, we can apply a low potential difference. Applications of electroplating. Electroplating is done in order to give the object that is subjected to plating a property that is lacking in it. The metal plate has a certain property which is lacking in the metal which is subjected to plating. So here are the desirable qualities that can be obtained by electroplating. Resistance to corrosion, attractive color, luster or shine, and good finish. And here are the metals that can be used for the process of electroplating. Copper, silver, gold, nickel, and chromium. Electroplating nickel metal on iron trays protects it from rusting and also gives it an attractive appearance. Electroplating copper jewelry with gold adds value to it and gives it a rich look. Vases, trays, cutlery, and door locks offering a golden or silvery luster is done by electroplating.